Hello, I am Sanjay Yadav. This video focuses on detecting malware using a passive network traffic analysis. Instead of executing malware, I analyze a PCAP file using a Wireshark and Python to identify suspicious behavior and confirm malware presence. The goal is to detect infection using a multiple network parameter such as throughput, packet rate, protocol behavior, and communication pattern. So let's see in my PCAP file. So here is my PCAP file and I will open it in Wireshark and let's line by line, we will see each inferences that will confirm that there is some malicious communication. So my first inference is internal versus external IP. So let's come to conversations and IPv4. So the internal IP 10.9.25.9 is communicating extensively with multiple external IPs. This outbound communication is abnormal and indicates possible common and control activity. So let's come to our second inference, that is anomalous connection in growth. So, okay, we observe a sudden increase in connection count with a short time. The spikes indicates automated request generation, which is not typical of normal user behavior. It suggests a malware-driven activity. So let's come to our next inference, that is short-lived TCP connections. Uh, Here I have sorted TCP connections by duration. We can observe multiple connections lasting less than 0.1 seconds. Okay, here we can say that lasts less than 0.1 second. This indicates automated behavior because a normal user session do not terminate this quickly. Such patterns are typically generated by malware performing scanning or scripted communication. So let's come to our next inference, that is asymmetric data flow. In this communication, we can see a large imbalance in data flow. The external large imbalance in data flow. Like here, we can see like packets A to B transferred is 4 KB and packets and bytes B to A is transferred with this kbps. So the external server is sending significantly more data compared to the internal host. And this indicates payload download or data transfer controlled by an external activity. So let's come to our next inferences, that is long idle sudden activity. So for this, I will go in statistics window and then I will come in IO graph. The graph shows long idle period followed by a sudden spikes in traffic. Like here, we can see for a small duration, the graph is idle. Then after that, there is a spike. Then it is idle. Then after that, there is a spike. So this sleep and wake behavior is a known malware invasion technique where the system remains inactive and then suddenly becomes active. This indicates possible data exfiltration or command execution. So let's come to our next inferences and I will show these inferences with the help of graph. So our next inference is packet size distribution. This graph shows packet size distribution. The presence of large size packet confirm bulk data transfer, indicating a payload delivery. Our next inference is throughput graph. So here is our throughput graph. The traffic pattern is highly bursty with a sudden spikes followed by your idle periods. This confirms automated malware behavior rather than normal user activity. And this graph, the sharp spikes indicates burst data transfer, which is a typical in malware communication. So let's come to our next inference, that is packet rate. This graph shows packet rate over time. The sudden spikes indicates automated packet generation, which confirms abnormal behavior observed in Wireshark. So here, here we come to conclusion. By correlating multiple indicators such as short-lived connection, asymmetric data flow, bursty traffic, and abnormal communication patterns, malware presence is confirmed. This analysis demonstrated that passive network traffic analysis is effective for detecting malware without execution. Thank you.